Here is my example of a portal frame with a prop in the middle. This is quite a long span portal frame, so it's quite often we put in a prop in the middle. And in this case, it really is just a prop. There is no moment connection there. So this makes the vertical load carrying capacity quite a bit bigger, but your lateral load carrying capacity is no bigger at all. So if we put a 3D render on, we can see the different frame elements. So our stanchions and our rafters are made up of the same 460 UV section, and we've got a little 200 UC post in the middle. So we'll have gone through and applied the loading in various load cases. In this case, it's just gravity, live loads, and then we've got wind uplift, wind down, and earthquakes applied as point loads to the eaves. We can go into analyze and we can do the linear analysis. I've already done that, so let's look at the results. And here is the bending moment diagram for this particular load case. If you want to do the envelope load case, it looks very complicated because you've got multiple layers. These are bending moment diagrams for each of these load cases. If I look straight on at it, because it is a two-dimensional frame. So we can see just from this, by the magnitudes, the largest moments are going to be at the eaves and at the apex of the frame, which is quite common. And the color coding will give you what load case you're looking at. So if I pick out the particular ones, this is the load combination for gravity loads, and then we can click through it in the different load cases. So this is wind up and this is wind down, and so forth. So that's the analysis. I'm sure you're all familiar with how you analyze in Multiframe. The more complicated part is the design side of things. And first of all, on the design side, you need to check that you're using the right code. So in our case, we're looking at NZS 3404. Okay, so we're good to go on that. You can select either part, do it by each individual member, or if you want to be quick, you select the lot and go a quick design check. Now I'm doing a check, not a design. So I've already put in the sizes of the members that I'm using. I'm not getting Multiframe to actually design it. To do that, you click on the design. So let's click on the check. By default, it gives you a check everything. I don't normally check serviceability because I do that as a separate check. If I click OK, it'll run through the design checks, and we go up to our resultant pages. You can see here are the displacements, here are the reactions, member actions and max actions, and so forth. Right over on the right hand side, there's a tab marked design efficiencies, and we can see that from our simple frame, we've got our design efficiency. That is the applied load versus the capacity, and we can see that our column marked as number 4 is at 96% capacity in there, and the governing load case is the wind uplift across the building.